Sound is all around us, car engines, conversations and music. But have you ever wondered how fast it actually moves? And what if I told you that in space, sound doesn't even exist? In today's video, we're exploring the fascinating nature of sound waves and the science behind their speed. How fast is sound? The science behind sonic speed. To understand the speed of sound, we first need to understand what sound actually is. Unlike light, which can travel through the vacuum of space, sound needs a medium, like air, water or metal, to move. Why? Because sound is a mechanical wave, meaning it relies on molecules bumping into each other to propagate. When an object vibrates, like a drum or a speaker, it disturbs the molecules around it. These molecules pass energy along to their neighbors, creating a chain reaction of movement, which we perceive as sound. The nature of sound has fascinated scientists for centuries. The ancient Greeks, like Aristotle, believed that sound was carried by the air. But it wasn't until the 17th century that Galileo and Isaac Newton began forming mathematical explanations for how sound moves. In 1660, English scientist Robert Boyle demonstrated that sound cannot travel through a vacuum by placing a ringing bell inside a glass jar and removing the air. This proved that sound waves need a medium to travel. But how fast does sound actually move? That depends on three key factors: the density, elasticity, and temperature of the medium. In dry air at room temperature, sound moves at about 343 meters per second. That's over 1,230 kilometers per hour. But if you're underwater, sound moves about 4 times faster at 1,480 meters per second. And in solids like steel, a staggering 5,960 meters per second. You've probably noticed this delay when you see lightning before you hear thunder. That's because light travels almost 1,000,000 times faster than sound. The speed of sound isn't fixed. It changes based on temperature, pressure, and the type of material it moves through. Warmer air makes molecules move faster, allowing sound waves to travel more quickly. That's why sound moves faster on a hot summer day than on a cold winter night. In water, sound moves faster because water molecules are more tightly packed than air molecules, making it easier for sound waves to transfer energy. The same principle applies to solids. Because their atomic structure is even more compact, sound can travel through them the fastest. From music to medical imaging, from communication to navigation, understanding the speed of sound has led to some of the most important technological advancements of our time. And we're just scratching the surface. So the next time you hear a song, a siren, or even your own voice, remember, you're experiencing a mechanical wave traveling through the air at hundreds of meters per second. If you enjoyed this breakdown of sound waves, hit that like button and subscribe for more science content. And let us know in the comments, where do you think sound travels the fastest? See you in the next video.